raise the output vegetables separately and groceries separately. This is the case of classification in supervised learning. Next, in the case of regression analysis, in the case of supervised learning, so regression analysis, which is nothing but based on the statistical method to model the relationship between a dependent and independent variables. Okay. So here predicting one value based on the another value. For example, weather forecasting, salary of a particular person, etc. So in this example, a marketing company A who does various advertisement every year and get the sales on that. Okay. For example, and the advertisement they have spent $90 and particular year they have got the sales of $1,000. In the next year they have spent $120. In the next year. $1,300. So based on these values, these last 5 years values, the next year corresponding sales can be predicted. Okay, that is the case of regression analysis. Then in the case of unsupervised learning, next kind of learning is unsupervised learning. Here the name suggests unsupervised, that is machine learning technique in which models are not supervised using training data set. That is, they are not labeled. So here we can give the inputs are like raw data, that is unlabeled data. Cats and dogs are given as input. Then using the algorithm, we can predict which one comes under dogs and which one comes under cats. Okay, so this is the case of unsupervised learning. So unsupervised learning. Next, clustering is one kind of unsupervised learning. So clustering or clustering analysis is a machine learning technique which groups unlabeled data set. So we have plenty of clustering algorithms available like k-means, k-mediots, hierarchical clustering, and density clustering. So like that, plenty of algorithms are available. So using that algorithms, we can easily cluster the groups of data. So for example, in the raw data, we have different kind of fruits. So after that, the raw data are given as input to some kind of algorithms or models. Then it will cluster the different kind of fruits. Okay, next one, dimensionality reduction. So dimensionality reduction in the unsupervised learning. So dimensionality reduction is nothing but suppose we are giving an input with a size of 256 into 256 means. So in that case, the main features only we need to extract. So using that dimensionality reduction, we can extract the main features. Okay, so here the input, the number of input features, variables or columns present in a given data set is known as the dimensionality. For example, a human face detection. Okay, so in this case, we can use the face features like eyes, nose, eyebrow, etc. So that features we can using that features we can easily identify a particular person's face. Okay, so this process is to reduce the features is called dimensionality reduction. So so dimensionality reduction is nothing but a way to converting a higher dimension data set into a lesser dimension data set. Okay. Next one, we can move on to deep learning. So deep learning, we all know it's a branch of machine learning, or it's a subset of machine learning. Okay, so neural networks imitate the human brain, and so deep learning will also can do the imitation. Okay, so in deep learning, nothing is actually programmed explicitly. So we need to train, we need to give the data set. Based on the data set, we need to train the data set. Based on the training only, it can predict categories. Okay. So this is an examples of deep learning. So here in the input layer, initially we can, this is nothing but predicting the human face. Okay, initially we are in the data set, we have plenty of human faces are stored. So we are giving that into the input layer. Then patterns of, after the first layer, it is moved to a hidden layer. So in the hidden layer, it only get the features, face features from each human face. After that, finally, if that face features like eyes, nose, lips, eyebrows, etc. Then after that, it is move on to hidden layer 2. In the hidden layer 2, based on the face features identified in the hidden layer 1, it will identify the human faces and the output will be generated. This is a small example of deep learning. Okay, so this is the explanation for the previous diagram. Next, there are plenty of deep learning networks are available. Today we are going to see an example of convolutional neural network. Okay, these are some types of deep learning network, that is feed-forward neural network, recurrent neural network, CNN, restricted Boltzmann machine, and autoencoders. Okay, so because today's example is based on CNN, so we can see what you mean by CNN. So using that CNN, we can do an image segmentation problem, okay, using Google Colab. Okay, so CNN, as we all know, it's a deep learning convolutional neural network. It's a type of AI artificial neural network which is widely used for image recognition and classification. Right? So it's a network architecture for deep learning that learns directly from the data. So directly from the given data set, it can learn itself and it can provide or it's particularly useful for finding the patterns in images. That is to recognize the objects, classes, and its categories. Okay. So this is about the image. The next one, image segmentation.
Sadish sir. Sir, excuse me, 1 minute, sir. Yaro Google share பண்ணிட்டு ஒரு நிமிஷம் யாரோ ஸ்க்ரீன் ஷேர் பண்ணிட்டு இருக்காங்க, ஒரே நிமிஷம்.
ஓகே.
அவங்க ஜாயின் பண்ணிட்டு உங்களோட ஸ்க்ரீன் மறுபடியும் ஷேர் பண்ணுங்க சார்.
So is it visible now?
மீனாட்சி யார்? நீங்க தான் ஸ்கிரீன் ஷேர் பண்ணிருக்கீங்க.
Okay sir. Sir, now you can share பண்ணுங்க sir. Sorry sir.
Sir, is it visible now?
இல்ல.
No.
Okay. Now share பண்ணுங்க sir. Once again you can share sir.
So is it okay now, sir?
No sir, no.
Sir, is it visible? No.
No sir.
Let me check.
Just once again close and start.
Okay, sir. I will share it again.
Now you can. Okay sir. Sir.
Yeah. Okay.
It's sharing.
Okay, so okay. CNN. So I told you there are different kind of deep learning networks available. So in this, mainly we are going to focus on CNN, that is convolutional neural network. So it's already I told you, convolutional neural network. It's a type of artificial ANN, which is mainly used for image or object recognition and classification. Okay. So CNN or convolutional network. It's a network architecture for deep learning that learns directly from the data. Okay. So next one. So image segmentation. So in this problem, we are mainly going to do the image segmentation. So before that, we just go through what I mean by image segmentation. So which is nothing but a subdomain of computer vision and digital image processing. Okay. That is grouping of similar regions or segments of an image under a particular class label. Okay, that is called image segmentation. Okay, it's an extension of image classification. Okay, so after classification, we can also perform the localization in the case of image segmentation. For example, here in the image segmentation example, here there is a one object available in the image. That is in the classification, we have one object, that is cat. Okay, so here in the second image, cat image, we are doing the classification plus localization. That is, we are localize the cat in that particular image. Okay. Suppose in the case of multiple objects available in an image means we can using the object detection
Sir,
we are detecting.
Sir, 1 second, sir.
Sir,
The screen now not visible, sir. The screen.
Sir, also, can you please increase your voice a little bit?
okay, ma'am. Okay.
Thank you, sir.
So now is it visible, sir?
Yes, sir, visible, sir.
Okay. So here in the case of image segmentation, so image segmentation we can see in the first case there is a single object in an image. Okay. So or image single object we can easily single object classify பண்ணிருக்காங்க. In the next image, classification plus localization can be done. Okay. So next image the image classify பண்ணிட்டு it's a cat, then particular cat or location local cat position we are focused. So that is called a localization. In the second case, we have multiple objects. Okay, that is in that image we have 3 types of 2 cat and 1 dogs are available, right? Okay, so initially we are detecting the object in a particular image. Then after that, we are segmenting the instance. That is nothing but segmenting the different objects in that image. Okay? That is done in the case of second image of multiple objects. Okay. So types of image segmentation, there are mainly 3 types. One is semantic, another one is instance, and finally panoptic segmentation. Okay. In the case of semantic segmentation, border or boundary of objects belonging to a particular class is segmented. Okay, so these are types of image segmentation. Here we have A represents a normal image, then B represents the semantic segmentation. Here in this image we have 4 type of object. One is sea, another one is sky, another one is land, and the third one is human. Okay, so using the semantic segmentation, we are differentiating the object. So that is segments out a broad boundary of object belonging to a particular class. Okay, so particular class, the objects belonging to particular class are differentiated in the case of semantic segmentation. That is the case of first one. Second one, that is instance segmentation. Okay, so instance segmentation, which is nothing but which provides a segment map for each object in the image without any idea of class object belongs to. That is the end the class or idea classes are not mentioned in this. Here it is simply identifying the objects in the image. So here the humans are the objects in that image. So it is simply identify the 3 humans in a particular image. That is the case of instance segmentation. And panoptic segmentation, which is nothing but a combination of instance and semantic segmentation task. That is which gives a segment maps of all the objects of any particular class in image. So in the B, we can see that it identifies the different objects. That is sky, sea, and land, and human. That is a boundary is fixed for each object in that image in the case of semantic segmentation. But in the case of instance segmentation, it is only identify the required object, that is human, that is segmented. In the case of panoptic segmentation, combination of both instance and semantic segmentation represents the case of panoptic segmentation. Okay, so in deep learning, today we are going to discuss about the unit architecture. Okay, so I think some of you go through the unit architecture. Okay, so unit architecture with is nothing but here we are doing 2 kinds of operation, that is downsampling and upsampling. அதாவது பார்த்தீங்கன்னா initially we are giving an input image 128 into 128 into 3. ஓகே, அது image size வந்து நம்ம 128 into 128 into 3 கொடுக்குறோம். ஸோ down sampling பண்ணும்போது பார்த்தீங்கன்னா so the number of features will be increased. Okay, so number of features will be increased. See here, initially there are 16 features we are going to use in this input image. So அதுக்கப்புறம் பார்த்தீங்கன்னா that is increased to 32, then again 64 and 128, finally 256. But the size of the image is reduced. See, initially the input image size is 128, 128. அதுக்கப்புறம் என்ன 64, 64, then 32, 32, 16, 16, 8, 8. This is the case of downsampling. Once downsampling பண்ணதுக்கப்புறம் next we are going to do the upsampling process. Okay, so here in the case of upsampling process, the image size is increased. Then see, you can see so 8 into 8 in the then 16 into 16, 32 into 32, 64 into 64. Finally, the output 128 into 128. This is the final image. At the same time, here the features is again reduced. Here final features downsampling la வந்து 256, 256 in that become increased to 128, 128, then 64, 32, finally 16. Okay, this is what process is happening in the case of unit architecture. Okay, we can see some coding in the Google Colab. So I hope all of you know something about Google Colab. Google Colab, which is nothing but it is a Google research product. It's a collaboratory or collab, we can mention in short. That is a Google research product which allows anyone to write and execute arbitrary Python code through the browser. So using any web browser, we can write Python code in the Google Colab. It is mainly suited for machine learning and data analysis. Okay, so machine learning and data analysis purposes on the use control. Okay, let me share my screen. Okay, so first I will tell you how to log in into Google Colab. So you can open your Google Chrome. See, I hope my screen is visible. If screen is not visible, kindly let me know because
visible, sir. Visible.
Yeah, okay. So initially what you want to do is you just log into any of your Google account. Okay, so Gmail நம்ம வந்து ஏதாச்சும் login பண்ணிக்கலாம். Then sign in. So I will log in. Okay, then after that you can click over here. Okay, நம்ம இதில் கிளிக் பண்ணிட்டு இங்கே கூகுள் டிரைவ் அந்த மாதிரி நிறைய ஐட்டம்ஸ் இருக்கு, கான்டாக்ட்ஸ், டிரைவ், மீட், ஜிமெயில் எக்ஸெட்ரா. ஸோ இதில் வந்து லாஸ்ட் மோர் ஃப்ரம் கூகுள் ஒர்க் ஸ்பேஸ். ஓகே, கோ டு மோர் ஃப்ரம் கூகுள் ஒர்க் ஸ்பேஸ். தென் சர்ச் ஆப்ஸில் வந்து யூ கேன் சர்ச் கொலாப் ஆர் கொலாபரேட்டரி லைக் தட். ஓகே, ஸோ கொலாப், ஸோ இட் வில் display the collaboratory. Okay, collaborative app on the display panel. You can just click on to that app. So actually already I installed the same in my computer. Okay, so by clicking install you can install the same in your computer. Okay, so actually Google Colab main purpose enna pathina, so normally to run a high size of data set. Okay, or model create pandrukku we supposed to run huge amount of data set. Okay, huge amount of data வந்து load பண்ணனும். In that case நம்ம local system வந்து நம்ம RAM, memory எல்லாமே வந்து ரொம்ப லோவா இருக்கும். So for getting a high end configuration, so we can use the Google Collaborator. So Collaborator வந்து பாத்தீங்கன்னா they are providing high end configuration. Okay, so monthly we can pay some amount to getting the or 16 GB RAM வேணும், எனக்கு வந்து எவ்வளோ processing speed, then storage space etc. So we can define the our requirement. So based on that we need to pay some amount for monthly basis. Okay, ஸோ இது இப்போ வந்து நான் வந்து ஃப்ரீயாக இருக்கிறதா யூஸ் பண்ணுறேன் ஃபார் ரன்னிங் திஸ் எக்ஸாம்பிள் the guest user ID we can use. Okay, so I hope now you're clear about how to use collaborator, how to log into collaborator, right? So can anyone reply please? Okay, so next one so already I have done a coding. Okay, so idla vandu nama enna panna porona before that. Okay, so இதில் வந்து பார்த்தீங்கன்னா ஐ எம் யூஸிங் a data set வந்து பார்த்தீங்கன்னா IIIT ஓட டேட்டா செட் வந்து ஹியர் we are going to use. Okay, that is Oxford IIIT PET data set வந்து நம்ம இங்கே வந்து யூஸ் பண்ண போகிறோம். ஸோ இனிஷியலி pip install git hub tensorflow examples.git. Okay, so tensorflow model வந்து நம்ம இதில் யூஸ் பண்ணி we are importing the data set. Okay, so first வந்து இது நம்ம ரன் பண்ணிக்கலாம். So to run this code இங்க playங்கிற மாதிரி ஒரு பட்டன் இருக்கு. You click by clicking on that play button you can easily run the code. Okay, so it will install the tensorflow examples எல்லாமே வந்து அதில் இன்ஸ்டால் பண்ணிடும். Then next we need to import some header files. Okay, so header files import பண்ணதுக்கு அப்புறம் then you can click on play button, then it will execute that particular module. The next one here we are going to load the data set. Okay, that is data set and the data set or details. Okay, tfds tensorflow dataset dot load Oxford IIIT PET. Okay, so Oxford IIIT PET ங்கிறத வந்து ஒரு டேட்டா செட். ஸோ அதை வந்து நம்ம இங்கே வந்து லோட் பண்ண போகிறோம். ஓகே, டவுன்லோடிங் தி டேட்டா செட், அதாவது அந்த அவங்க இதுலேருந்து நம்ம இங்கே டவுன்லோட் பண்ணுறோம். நெக்ஸ்ட் ஒன், next we are not going to normalize the input image and input mask. Okay, so in this data set we have input image இருக்கும், input mask இருக்கும். Okay, input image அதோட சைஸ் வந்து பார்த்தீங்கன்னா நார்மலி இட் இஸ் 255-56 அந்த ரேஞ்சில் இருக்கும். தட் இஸ் we are reducing the size of the input image or normalize the size of the input image. Okay, then next one அது நார்மலைஸ் பண்ணதுக்கப்புறம் next we are going to load the image into our collaborator. Okay, அந்த கூகுள் டிரைவ் இருக்குல்ல, கூகுள் டிரைவில் அந்த கொலாபரேட்டர்களுக்கு வந்து next we are going to load the image. ஆக்சுவலி லோட் பண்ணிட்டேன், அதர்வைஸ் இது வந்து எவ்வளோ டைம் வந்து it will shows how much it will take to load. 90-100% வரைக்கும் லோட் ஆகும். Okay, then next one we are going to ட்ரைனிங், அதாவது ஹியர் we need to ட்ரைனிங்க்கும் டெஸ்டிங்க்கும் வந்து எவ்வளோ டேட்டா வந்து ப்ரொவைட் பண்ணணுங்கிறது வந்து we need to mention. ஓகே, ஸோ அந்த ட்ரைனிங் அண்ட் டெஸ்டிங் டேட்டா வந்து பார்த்தீங்கன்னா okay, so here the training length பார்த்தீங்கன்னா the number of data available in the data set பார்த்தீங்கன்னா 3700 data sets வந்து இருக்குது. அதில் வந்து 50% வந்து பார்த்தீங்கன்னா ட்ரைனிங் அண்ட் டெஸ்டிங்க்கு வந்து இங்கே யூஸ் பண்ணுறோம். ஹியர் ட்ரெயின் லெங்த் வந்து பார்த்தீங்கன்னா we need to create a batch size. அதாவது ஒவ்வொரு பேட்ச் சைஸ் கிரியேட் பண்ணிட்டு அந்த பேட்ச் சைஸை தான் வந்து we are going to finally given for the training and testing. Okay, so here the buffer size mentioned as 1000. Then steps per epoch, நம்ம எவ்வளோ ட்ரைனிங் லெங்த் கொடுத்துருக்கோமோ அது டிவைடட் பை பேட்ச் சைஸ் கொடுத்தோம்னா வந்து we can get the epoch. ஒவ்வொரு ஸ்டெப்ஸ் எத்தனை எப்போக் வந்து எவ்வளோ ஸ்டெப்ஸ்ங்கிறது we can get. Okay, then next one train images. So okay, so here train images, then test images. So train images and test images data set la நம்ம differentiate பண்ணிக்கிறோம். Then after that using the class argument. So this class argument actually நம்ம எதுக்கு யூஸ் பண்றோம்? இப்போ ஒரு இமேஜை வந்து for example mobile is an image. Okay, so the mobile image வந்து we can have different kind of faces. அது ஃப்ரண்ட்ல பார்க்கலாம், சைடு அண்ட் பேக் வியூ. ஸோ யூஸிங் ரேண்டம் ஃபிளிப் பண்ணி டிஃப்ரெண்ட் பொசிஷனில் வச்சுட்டு அது இமேஜஸ் வந்து ஹவு வி கேன் ஐடென்டிஃபை இட் இஸ் அ மொபைல் or it is a dog, it is a cat. Okay, so that random flip can be done using this class augment. Okay, so class augment. Then after that, train batches. Okay, so here we are doing the train batches, that is train images, a number of train images all over, then buffer size, batch size, then augment, etc. Then finally here next we are going to display method. This display method is mainly used for display the sample images available in the data set. Okay, so these are the sample images. For example, a cat image irukkudu. So here sample images for images mask in train batches take 3. So take 3 means train batches we are taking 3 images, and simply we are displaying the images by calling the display function. Okay, sample image adoda sample mask, true mask display pandrom. So let me run the code now. Okay, so it has taken 3 different images. That is input image of 3 dogs. 3 dogs are input image adoda true mask. It is displayed. Okay, so these images are taken from the IIIT data set, Oxford IIIT data set. So after that, now okay, next we are going to define the model. So from this coding onwards, we are focusing on the unit model. Unit model we are going to do. So here, so as already I told you, unit model consisting of encoding, that is downsampler, or decoding, that is upsampler. So here the encoding, that is downsampling, can be done using the MobileNet V2. Okay, MobileNet V2 applications use panni, we can do the downsampling. Here you can see the image size is reduced. Downsampling பண்ணும்போது 64, 64, 32, 32, then 16, 16, 8, 8, then 4, 4. Okay, then so while clicking on the run button, we can run the base model. Then next one, we are doing the upstack. That is upstack, which is nothing but upsampling or decoding we are going to do. Here it is again, the size is increased. Okay, 8, 16, 32 and 64 are again upsampled. Okay, next we are defining a function for the unit model. Okay, so here we are doing the downsampling through the model, then upsampling. So in the case of that is 12 and 13 modules, they are mainly used for downsampling and upsampling. Here we are calling that functions, downsampling and upsampling functions. Then this is the final layer, that is convolutional layer used panni we are predicting the output. Okay, so now unit architecture or unit model is created. Okay, now okay, now we are plotting a model. Plotting a model for how we are doing the downsampling and upsampling. So in this diagram, you can see here the input image size is 128, 128, and the input layer. So the output is 128, 128, and 3. Okay. So here we are doing the downsampling. See, the 128, 128, 3 is reduced to 64, 64, 32, 32, 16, 16, 8, 8, 4, 4. Okay. Then, so here it is likewise, it is downsampled. Okay. Next, we are creating a mask for each image in the data set. Okay. So here we are defining the mask. Then after that, we are defining a functions for the predictions. So by calling the show predictions method, we are simply loading only one image from the data set. So this is the input image and true mask from the data set. Before giving the training, we are just predicting a mask. So this is the output. After the training, we can see after the number of epochs, we can see how the output become. Okay, so here the number of epochs given is 2, and see. Number of epoch given is 2. So I think each epoch execution time, it will take a minimum 5 to 10 minutes for doing the epochs. See, there are 57 batches in each epoch. Okay, so one batch I already told you there are 64 images available. Initially, we have mentioned the image batch size, that is 64 images on the batch. And there are 57 batches on the epoch go through. Okay, then only it will predict the first output. Then in the second epoch, it will provide much more better output. Okay, so this is the case of unit architecture. That is how unit architecture is used in IIIT PETS data set for predicting whether it is an animal or it's a dog or cat inside that PET data set. So this is about how we can do a sample program or how do we create a unit architecture model using Google Colab. So I hope now you have got a little bit idea about how we can do some kind of model creation and data set downloading from a particular site to Google Colab, etc. So if you have any queries in this, you can. So Ganeshan sir, is it okay now? Hello?
Yes, sir. Just participants, you can ask any queries.
If you have any queries, you can ask. So the important thing, as all of you want to know, if we are going to build any model, so our system configuration is not enough to build any kind of models. Okay, so we can use Google Colab. Okay, using that Google Colab, you can build models.
Good afternoon, sir.
Sir, good afternoon. Yeah, Solung sir, tell me.
Yeah, I am Dr. Balaji from Mohambiya College.
Sir, Solung. Yes, yes.
Sir, Google Colabs மட்டும்தான் யூஸ் பண்ண முடியுங்களா? Some mathematical models or any other tools like TensorFlow or PyTorch?
Yes, sir. Actually, Google Colab it's a kind of Google collaboratory. Or system system we don't have that much configuration. For example, a model create or data set load we need high-end configuration like 16 GB RAM, 1 TB hard disk capacity, or processing power on the high-end processing power. But actually, our local systems, it will not provide that much configuration. Okay, so in that case, Google Colab configuration provide pandra or area, that is cloud or cloud configuration providing area on the Google Colab provided by the Google sir. So the providers different kind of collaboration. Google Colab providers available sir.
Okay, sir. Thank you. Okay.
Any other queries, sir? Please ask.
Actually, Asana, Trello, Slack, and different kind of configuration providers are available. Okay, that is Dropbox. That I'm already used so they are also providing some kind of Google that is in the collaborator Mari cloud storage they are providing. Not only cloud storage, cloud configurations also they are providing. So I will share this PPT and this code to Ganeshan sir. You can use this code and PPT. Okay.
Okay, sir. Okay, sir. At the end of the session, I'll give it to all participants, sir.
Okay. There are plenty of sample codings like this available in the website. Okay. And also data set is available, different kind of data set, especially the Kaggle. Kaggle, you can get a different kind of data set. So using that data set and some similar kind of codings like this, you can execute or you can create models using Google Colab. Okay. So Google Colab only I am using free configuration. Free I am using. So better if you paid some amount for the monthly basis, you can get a high-end configuration in the Google Colab.
Sir,
Sir,
ஒரு சின்ன டவுட் சார்.
சொல்லுங்க.
ஆக்சுவலா மிஷின் லேர்னிங் அல்காதம்ஸ் இனிஷியலா ஸ்டார்டிங் டேஸ்ல இருந்துச்சு. அப்புறம் ஏஐ, அதுக்கப்புறம் வந்து இப்ப டீப் லேர்னிங் அப்படின்னு மாறும்ல சார். ஆனா டேட்டா மைனிங் வந்துச்சு இதுக்கு முன்னாடி. பட் எல்லாத்துலயுமே நம்ம அந்த மிஷின் லேர்னிங் அல்காதம்ஸ் இந்த கான்செப்ட்ஸ் தான் ரிப்பீட்டடா பார்த்துட்டே இருக்கும். இந்த டீப் லேர்னிங்கிறது அந்த சிக்னிபிகன்ஸ் ஏதாவது இருக்கா சார்? அதாவது இந்த இடத்துல வந்து இந்த டீப் லேர்னிங் அப்படிங்கிற அந்த வேர்ட் நம்ம காயின் பண்ணிருக்காங்களா சார்? அது ஏதாவது ஒரு சிக்னிபிகன்ஸ் இருக்கா அதுக்கு? ஏன்னா நம்ம டேட்டா மைனிங்லயும் இதான் லேர்ன் பண்றோம், ஏஐலயும் தான் லேர்ன் பண்ணிருக்கோம். மிஷின் லேர்னிங் அல்காதம்ஸ் இயர்லியர் டேஸ்ல இருந்து நம்ம இந்த அல்காதம்ஸோட தான் டிராவல் பண்றோம், நியூரல் நெட்வொர்க் எல்லாமே. பட் நம்ம இந்த கன்வல்யூஷன் நியூரல் நெட்வொர்க்னு வருது, டீப் லேர்னிங் வருது, இமேஜ்க்காக மெயினா நம்ம இது கன்வல்யூஷன் நியூரல் நெட்வொர்க் யூஸ் பண்றோம், டீப் லேர்னிங் யூஸ் பண்றோம்னு சொல்றோம்ல சார். அது ஏதாவது சிக்னிபிகன்ஸ் எதுவும் இருக்கா, இல்ல சும்மா ஜஸ்ட் நேம் தான் அந்த மாதிரி?
அதாவது பாத்தீங்கன்னா மெஷின் லேர்னிங் வந்து த்ரூ எக்ஸ்பீரியன்ஸ் இட் கேன் லேர்ன். அதாவது ப்ரீவியஸ் பாஸ்ட் டேட்டா பேஸ் பண்ணி மெஷின் லேர்னிங்ல வந்து டேட்டாஸ் வந்து லேர்ன் பண்ணுது. டீப் லேர்னிங் தி வேர்ட் இட் செல்ஃப் வி கேன் ஈஸிலி ஐடென்டிஃபை. டீப் லேர்னிங்னு பார்த்தீங்கன்னா அதாவது ஒரு இமேஜ் எடுத்துட்டீங்கன்னா அதோட இன் டெப்த்ல டீப்பா போயிட்டு வி கேன் லேர்ன் தி ஃபீச்சர்ஸ். ஃபார் எக்ஸாம்பிள் நான் ஒரு எக்ஸாம்பிள் சொன்னா அந்த ஃபேஸ் ஐடென்டிஃபிகேஷன் சொன்னேன் இல்லைங்களா? ஃபேஸ் ஐடென்டிஃபிகேஷன் சிம்பிளி ஒரு ஃபேஸை பார்த்தோம்னா ஐடென்டிஃபை பண்ண முடியாது. ஸோ அதோட ஃபீச்சர்ஸ் லைக் ஐஸ், ஐப்ரோ, லிப்ஸ், நோஸ், அந்த இன் டெப்தா போயிட்டு அந்த ஐஸை மட்டும் ஐடென்டிஃபை பண்ணணும். இமேஜில் வந்து அதை மட்டும் செக்மெண்ட் பண்ணணும், ஐஸை மட்டும் இல்லைன்னா ஐப்ரோ மட்டும். ஸோ அதுல இருந்து பேஸ் பண்ணி நமக்கு வந்து வி கேன் ஐடென்டிஃபை எ பர்டிகுலர் பர்சன்ஸ் ஃபேஸ். ஃபார் எக்ஸாம்பிள் ஒரு குரூப் ஆஃப் பர்சன்ஸோட இமேஜ் இருக்குது. அதுல வந்து ஒரு பர்சன் வந்து ஒரு தீஃப், அந்த பர்டிகுலர் பர்சனை மட்டும் நம்ம ஐடென்டிஃபை பண்ணணும். நமக்கு பார்த்தீங்கன்னா வி ஹேவ் தி ஃபீச்சர்ஸ் ஆஃப் தட் பர்டிகுலர் பர்சன். ஓகே, ஸோ நம்ம ஒரு மாடல் கொடுத்து அந்த பர்டிகுலர் பர்சனோட ஃபீச்சர்ஸை வச்சு நம்ம டேட்டாவை ட்ரெயின் பண்ணலாம், மாடலை ட்ரெயின் பண்ணலாம். ஸோ அப்போ அந்த இமேஜ் இன்புட் கொடுக்கும்போது அந்த பர்டிகுலர் பர்சனோட ஃபேஸை வந்து அது ஈஸியாக வந்து கரெக்டாக ஐடென்டிஃபை பண்ணி கொண்டு வரும். ஸோ தட் இஸ் தி கேஸ். அப்போ டீப் லேர்னிங்னா வந்துன்னா பர்டிகுலர் ஒரு இமேஜில் இருக்கிற பர்டிகுலர் ஃபீச்சர்ஸை வந்துட்டு டீப்பாக வந்து அதோட லேர்ன் பண்ணி அந்த பர்டிகுலர் இமேஜோட ஃபீச்சர்ஸ் எல்லாமே ஐடென்டிஃபை பண்ணுறது. அதான் அந்த டீப் லேர்னிங் நம்ம மீன் பண்ணுறது. எஸ் சார்.
ஓகே, தேங்க்யூ சார்.
யா, வெல்கம் சார்.
Any other queries, participants?
So the unit architecture is one of the main important architecture used for nowadays for doing the research. So if you have time, you just execute this coding in your Google Collaborator. Okay, so you will also get a good experience of how to use Google Collaborator. Okay. Yeah, Google Collaborators, I told you, it is mainly used for doing some kind of machine learning and deep learning algorithms. Yeah.
Okay. So this, sir?
Yeah, yes, sir.
Okay, sir. You can conclude, sir, this session.
Okay, sir. Okay, fine.
Participants, thank you very much for participating this first day event. So another information. So the attendance will be monitoring by using the Google Meet attendance. The feedback, the only one feedback at the end of this FDP final day will provide you feedback link. So there's no feedback, daily feedback. Then the session starts from 12 o'clock sharply, and 12 to 1 will be the session every day.
Okay, so let me give a small vote of thanks. So first of all, I would like to thank Hindusthan management for providing such a wonderful opportunity, and the coordinator Ganeshan sir and the HOD Department of IT for giving us such a wonderful chance for presenting the same. Thank you, sir. Thank you so much.
Thank you, Sadish sir. Thank you for your even in your busy schedule, you gave a session. Thank you very much.
You, sir. Yeah.
Thank you, participants.
Thank you, sir.
Okay. Now we can wind up. If any doubts, you can clear in this session now, or otherwise you can leave the session. Tomorrow we'll meet at the same time, 12 to 1.